Okay, guys, in this question, we are going to take a look at the problem of using the second derivative test to find the maximum, minimum, or saddle points of a given function. All right, so what do we do first? So first, let me copy down the function formula. So it's just going to be a pretty simple example because it looks like there's only one critical point here, which is going to simplify things. Okay, so this is going to be 86. All right, so let's find the partial derivatives, and I can just do that over here. So first, we are only going to, actually, because I want to highlight, I want to only highlight terms that have x. And then the other terms I'm not going to highlight because they are going to disappear and become 0. So this is going to be just 16x plus 48. Then I am going to only highlight terms that have y. Okay, so that means that it's going to be this part, and that's it. The 86 is a number. Okay, so that I will take the derivative of, so that'll be 8y minus 16. Now, when we set this equals 0, it's going to be pretty easy to find the solution. So 16x plus 48, when we set this equals 0, subtract 48 from both sides, that gives you 16x equals negative 48. Then divide both sides by 16, which is going to cancel that here. And it looks like that's just going to be x equals negative 3. Now, from the second equation, when we set that one equals 0, you can probably guess that the answer is 2. Now, what you should do next is to take these values, negative 3 and 2, and plug them back into fx and fy and make sure they're zeros. But because this is such a simple case, you can pretty much easily see that immediately when you substitute those values, you are going to get 0 for both fx and fy. All right, so what do you do next? Next, you need to use the second derivative test. Now, I always highly recommend using Desmos calculator to do that. Okay, because I am allowing you to use it. Now, some teachers don't, and then you will have to do this by hand. Okay, so sorry about that. But what I'm going to do is first find all these second partials. So fxx means that I am taking this guy and taking the derivative of it with respect to x again, which is just going to give me 16. Then I'm taking the same exact guy and taking the derivative of that with respect to y now. Well, because there's no y in there, that's just going to be 0. And fyy means that I'm taking the y derivative and taking another derivative of it with respect to y. Which, by the way, if I took the derivative of this with respect to x, that would actually be fyx, which is called a mixed partial, and it should be the same as the other one, and it will be because this does not have an x, so that's going to be 0. All right, so once you do that, what I recommend doing, especially when it's a more difficult case, this is not a hard example for sure, for sure. So here I'm just gonna put F, then I use underscore of my keyboard, so that's like shift and minus, okay? And then I'm putting XX, x comma y equals 16. Then I'm doing f x y x comma y equals 0. Then I'm doing f y y x y equals 8. Then I'm going to compute something called d. Okay, and this d is going to determine what type of point you're going to get. So here's the formula for d that you must I don't think you're going to have to memorize it because I will include it, but at least you use it multiple times so that you know how to use this result. So you're going to take fxx, and I'm just going to copy paste it because I don't want to type it again, and then multiply that by fyy. Then you're going to subtract minus and fxy, copy that, and then you square that. Okay, so it's important because some people forget to square, which is going to be a big problem because sometimes you'll get like a 0, and you never should ever get a 0 for d. If you get a 0 for d, that tells you that you did it wrong. Now, theoretically, it is possible that d is a 0, but that's such a weird case that you guys are never going to see that on homework questions. All right, and then I also need to plug in the point that I have, okay, into d. So I actually need to use d of x, y, generally speaking, so that I would just find what is d of negative 3, 2. In this case, they're all numbers, so it doesn't matter. It's going to be 128. But generally, what if you had multiple critical points that you'd have to plug in here? So just use x, y there. Now, I also need to plug in this point into fx6, and that gives me 16. So the result is the following. If d is negative, then you get a saddle point. But d is not negative here. So if d is positive, so d in this case is more than 0, then you have to also look at fxx. So is fxx positive or negative? If fxx is positive, then you have a minimum. So it's kind of like the opposite. But if d was positive and fxx was negative, you actually will get a maximum. And again, if d was negative, then that's just a saddle point. So for me, in this case, this is local minimum. And now to figure out the value, like why would I want to do that? Well, you want to know what is the actual point on the graph of this surface. So you would have to plug this point into the original function. So I'm just going to have to type it into Desmos because I'm not doing this in my head. So I type it and then I just plug in the point and I get negative 2. So the point on the surface where the minimum is going to occur is going to be negative 3, 2, negative 2 for the z coordinate, okay?